Greetings, class. Welcome back. Good news is we have 2 weeks left of the semester, so I hope everybody's hanging in there and you're safe and healthy. So let's get started from where we left off in the last video. We're going to do a t-test. This is a 2-sample t-test as opposed to a single sample t-test. So Chapter 8 was hypothesis testing. Chapter 9 was our single sample t-test. Now we're into Chapter 10, which is a 2-sample t-test, which is by far a more common way to do research when you have 2 groups. And so in this case, we're selling beer, I think it was, and we have people indicating how much they're willing to buy this product on a 10-point Likert scale, with higher numbers meaning you're more likely to buy it. And what we have is a celebrity spokesman in our advertisement or some average Jane or Joe, okay? And we set up our hypotheses. So the null hypothesis would say that we're going to see equal ratings for the 2 groups, or we could say it this way: if we compare the two, remember subtraction is comparison, we'll get no difference. And then the alternative hypothesis is that the 2 groups will not be equal, so when we compare them, it's going to be something other than 0. Okay? Of course, we're not going to take the 0 literally, just like we've done in the past. We're going to say, well, is it different enough from 0 for us to conclude that there's a difference? So our step 2 is up here, and we're going to use an alpha level of 0.05. Okay. Now, I mentioned that what we're going to do is, because we have a t-test, we're going to make guesses about variability, and so we're going to need to use degrees of freedom. Okay. To get our critical value for our t, we're going to take the degrees of freedom for the first group plus the degrees of freedom for the second group. Okay, so we have 6 people, so the degrees of freedom is 5. 6 people, degrees of freedom is 5. And so we're going to do 10 degrees of freedom. Okay, and if you look up the critical value in the back of the book, right, in that t distribution, for 0.05 with 10 degrees of freedom, our critical value is 2.28, okay? And that's plus or minus 2.28, okay? And remember that corresponds to the extreme 5%. So instead of a z-score would be 1.96, our t-value is a little bit more than that. We just have to adjust, so it's 2.228. So here's where we left off. This is our t-value, okay? We're going to calculate the t, 10 degrees of freedom. The numerator for this statistic should make sense to you, okay? Let's think about it. We're going to compare the average for the celebrity, and we're going to compare that to the average Jane or Joe. So we get the average for the celebrity, 5.50. We're going to compare that to the average Joe mean, and that's 6, okay? So that's sort of, I think, it should make sense intuitively. This is the question. Is this group different from this group? Okay, is this group different from this group? So we're just going to subtract, okay? We're going to make that comparison. So the question is then, what are we going to use for this value? And if we think back about previous videos, remember the form of this statistic is difference over variability, difference over variability, difference over variability. So this is going to be a measure of variability, okay? Now, I think I left you with some homework, and that is, let's get the sum of squares for each of these groups. That's going to give me my building block for variability. And hopefully you did that. If you didn't, I would request that you do, just so you know how to get the sum of squares. I mean, that should be old news, right? Kind of review. Sum of squares for the first group is 29.50. Sum of squares for the second group is 28. Okay, so hopefully you got that. We're going to use those two building blocks of variability to get to this number for variability for this two-sample t-test. And let me show you how this works, okay? So here we are. I'm going to go over here first. I'm going to go here first, okay? Because I want you to remember the single sample t-test. Remember, there were two steps. There were two steps, okay? We're going to retain those two steps. Don't look over here yet, okay? I want to do this review. I want to do this review for single sample t-test. We got S. Remember, S was our guess. S was our guess. What was it our guess for? Remember, S was our guess for sigma, okay? S was our guess for sigma. And we arrived at that by getting the sum of squares, dividing by degrees of freedom, take the square root, okay? So that was our guess for sigma. And then this was our old step, the central limit theorem step, where we then took our guess for sigma, divided it by the square root of n, that gave us our S sub m, okay? This should be review. If it's not review, go back and look at it, okay? Because it will help you with this new stuff. So we sort of have to get the conceptual, it's the same conceptual stuff. We're going to make a guess for sigma, and then we're going to convert to central limit theorem and put it in our t-test. So, excuse me, we're going to do the same thing here, except in a way, what we're going to do is we're going to use the sum of squares for each of the groups, okay? We're going to use the sum of squares for each of the groups. So we're going to put sum of squares for the first group plus the sum of squares for the second group. And we're putting those together, and we're going to call that the pooled variability, okay? Pooled, P-O-O-L-E-D. Just like if we were going to, see if we have enough money to get beer, we might pool our money, right? Put it together. So we're going to put these, the variability together. So I'm going to subscript this with a P. That's just a subscript. That's telling you this is a measure of variability that's pooled across two groups, okay? Also, you'll see that instead of S, this is S squared, okay? So instead of taking the square root, we're going to not do the square root yet. We'll do it in the next step. It's the same thing, okay? But we're just going to wait until the next step to take the square root. So this is pool variability. Make sure you take notes, okay? This is pool variability because we're pooling both of the groups together. And since we're not taking the square root, this is little s squared. This is just a subscript, okay? Pool variability. All right? Let's go back to our numbers, our celebrity group, the average Joe group, okay? Sum of squares for this, sum of squares for this. Now, what we're going to do is put these two variabilities together, because what we're going to assume, this will be a test question for sure, okay? What we're going to assume, if there's no treatment, that is, if there's no difference, then we would expect both of these variabilities to give us some kind of a guess for the underlying single population. Let me say that again. If there's no treatment effect, if there's no difference, then they both came from the same population, so we're going to be able to use both of these to make a guess for sigma. That's a little bit more straightforward than thinking about a situation where, well, what if they come from two different populations? Do we really want to pool them together? And the answer is yes. And that's because, this is something I mentioned before, we're assuming that if there is a treatment, it just pushes the curves around. It just pushes the curves around. It doesn't change their variability. This is a very important concept, okay? So if there is a treatment effect, if there is a difference, we can still use these because we're assuming the treatment just pushes the curves around, but it doesn't change the variability. If we end up failing to reject the null, that is, if we say there's no treatment, well, then they both came from the same population, so we can put them together. So whether we say there's a treatment or not, we're going to be able to put these two together. And we're going to assume that we have homogeneity of variance. That's an assumption in statistics. I'll say it again. We're going to assume that there's homogeneity of variance. That is, that the variances here are homogeneous, that they're similar, they're equivalent, they're the same, okay? So we're going to put these two together. We're going to use both measures of the group variability. We're going to pool those together to give us our best guess, Because these are they're not equal, but we're assuming they're homogeneous. They're similar enough that we can put them together. Okay? So that's the conceptual. The mathematical, guess what, you guys? You just follow the formula, okay? And we'll be careful to do, to look at the formula and plug in the numbers that need to be plugged in that case. Okay? Homogeneity variance. These should reflect about the same variability. We're going to be able to pool that together because if there's no treatment, they came from a single population. If there is a treatment, that is, if we end up rejecting the null, we still will assume that treatment just pushes the curve around. It doesn't change the variability of the curve. Okay, that's the conceptual. I'll be asking that. Let's do the computational. Okay, so we're going to do 29.5 plus 28. Is that what it was? 28? 29.50. Okay. Add those together. Degrees of freedom for 1 plus degrees of freedom for 2. So this is 5 plus 5. Right? We had 6 in each group. 5 plus 5. Okay? I have to get my calculator. Hold on now. Hold on. You guys got it? I could almost do this in my head, right? 29.5 plus 28 equals 57.5 divided by 10. So 5.75, right? So this is 5.75, okay? Just set it up like this so you can keep your wits about you, right? And don't split this up. It's not 29.5 divided by 5 plus 28 divided by 5. That's not what this recipe tells you, okay? You have to be able to follow the recipe. Add these together, 29.50, 28, 5 plus 5, so it's 57.5. Now you divide by 10, so here's our answer. Okay? So this ends up being our guess for sigma, but it's actually our guess for sigma squared. We'll take the square root. Just follow the recipe. The concept here is this is our guess for what's going on with population variability. Same as here, except this is squared. We'll take care of that. Then here, this is our central limit theorem step, just like here. You can see the similarities, right? Now, be careful, because we are going to split this up, okay? This has the line all the way across, so you don't split it. This one does not have the line all the way across, so you split it. I'm just going to take my pooled variability, put it in here, so it's 5.75. Be very careful. Here's where people make mistakes. Follow the recipe, follow the recipe, follow the recipe. This doesn't say degrees of freedom, it says n. So we're going to divide by 6 plus 5.75 divided by 6. Okay. Follow the recipe. And by the way, you see that these are the same, but if the two groups had different sample sizes, back in our celebrity and our average Joe, if it was different sample sizes, and I'll do an example with different sample sizes, then you'd see a difference in these two numbers. Now make sure that you take the square root. That's another very common mistake that people make. They don't do the square root when they get to this point. Follow the recipe, stay organized, okay? So I have 5.75 divided by 6.96 plus 0.96. So this is the square root of 1.92, something like that. Okay, so let's take 1.92, get the square root, and that is 1.39, let's call it 1.39. Okay, pretty good. 5.75 divided by 6. Let's do that again. Make sure we got the right number. 5.75 divided by 6. Okay. Double that, 1.92. Take the square root. We got 1.38 or 1.39. Okay. Depends on where you round. 1.39. Okay. This is a subscript, folks. Don't get confused about subscripts. This is still our little s. This is still our little s. Remember, little s subscript m? This is little s subscript m1 minus m2. It's telling us that this is based on two samples, on pooled variability, rather than just one sample. Okay? 1.39. This is our guess for our guess for sigma. It's actually our guess for sigma squared. But see, now we're going to do the whole square root. That's how it differs here. Took the square root here and put it in. Here we didn't take the square root, so we'll just take the square root of everything. I'm not worried about that. You don't have to derive this. This is not a math class, right? Just follow the recipe. And that is what goes into here, okay? So basic building blocks, sum of squares. You guys know what degrees of freedom are now, right? Put those in there, follow the recipe, and put the S, let's do this P here because that's what you're going to see in the formula, right? I wanted to wait to do that till I explain what pooled variability is. Put that in, divide by n, plus put that in, divide by the n for the second group. Square root of 1.92 is 1.39. So here we go. The difference between the two groups is 0.5, 0.5, and in fact, it will be a negative 0.5. We're going to divide by 1.39. We have a t value. Let's get it. 0.5 divided by 1.39. Okay, so our t is 0.36. That would be negative. Okay, the difference that we see is 0.36 of the variability. So let me ask you, before I go further, do you think we're going to reject the null, or fail to reject the null. If you said fail to reject the null, you are correct, right? Because here's our critical value for 10 degrees of freedom. It's plus or minus 2.228. So the top has to be 2.228 times the bottom or more, right, to get it that far out. And in this case, it's not even close, okay? We're really close to the center of this curve. And so, in this case, go back here. So this would be all step 3, right? This would be all step 3. You'll be given these formula, okay? Just Matryoshka doll them right in. Step 4. Fail to reject the null because it didn't go beyond that critical value. Okay? Let's go back to the null. The null said that the two groups were going to be equal. The null said that there's going to be no difference. When I say the difference is 0, I don't mean that literally. I mean it probabilistically. And so we fail to reject the null. And I would say it appears that having a celebrity, oh my goodness, that is, having a celebrity spokesperson does not affect, with an A, right, because it's a verb, does not affect, let's say, ratings of interest in buying the beer. Now, in this case, my T with 10 degrees of freedom, right? Because once again, and some of you on the exam forgot to put this, it's very important to put this parenthetical information, because otherwise it's like, you know, it seems like an opinion. So I want to show people, this is why I'm saying there's no effect, okay? Does not affect. We got a T value of minus 0.36. I'm always going to put the observed value here, okay? And then the P now is greater than 0.05. That is, there's a greater than 5% chance that I'm going to see a difference that looks like this, okay? A T value. Okay? So, that is a two-sample t-test. A two-sample t-test. So, let's do another example. Let's do another example from start to finish. And we'll see if we can't, you know, just go right through it, given the formula and stuff. Let me, trying to think about, sorry about that. I might have made a little bit of noise. So let me tell you about a research project that I did, and boy, I wish I could show you. Maybe I will email a picture of this artwork. Well, anyway, let me explain a study that I did a few years ago. I fancy myself as an artist, and I was on the board of directors here in Utica at a place called Sculpture Space. And that's an international residency program for modern sculptors. And so we would have opening receptions, and some of the sculptures that I saw were these are modern sculptures. And I remember seeing some of the stuff. I'm like, what the hell is that all about? I mean, it just looks like garbage, you know? And then the artist would start talking about what she was trying to accomplish with these sculptures. And I was like, oh, well, that's pretty cool, right? That's pretty cool. and I've taught creativity a couple times in the psych department, and I have people looking at a lot of artwork, and I oftentimes will notice that people are sometimes uncomfortable with abstract artwork because they want to know what it's supposed to be, and of course you don't want to ask an artist that because I mean it is what it is, right? And so one of the things I was interested in as a psychologist and an artist, so I'm able to put both of my interests together, is how people will respond to artwork, abstract artwork, if they just look at it, or if they look at it and there's an explanation of what the artist is trying to accomplish. Okay? And so what I did was I had some people look at artwork, I just had them look at the artwork and had them rate it. How much do you like this artwork on a Likert scale? And then for another group, I had them read an artist statement where the artist is explaining what they're trying to accomplish in the artwork. And then I had them look at the piece of art and have them rate how much they like it. Okay? Now, whether or not you agree that artwork should have to be explained is a whole other story. I mean, we could talk about that. But I wanted to see if we'd see differences in the ratings of artwork without an artist statement. So here is one of my groups is without the statement. And another one is with the artist statement. With that explanation about what the artwork is supposed to be accomplishing. Okay? So those are the two groups. Let me put some numbers in. And this time we're going to use unequal group sizes. And you'll see where that comes into play in our formula. Okay? So we'll just, again, we're going to use simple numbers here. We will do a Likert scale from 1 to 10. So this is how much people like the artwork, where a rating of 10 is the highest. They really like it. So without the artist statement, people are going to look at this abstract painting, and let me just put some numbers in here. Yeah, let's do this. So there's 6 people that look at it without the artist statement, okay? And let's do this. This is people that have the artist statement. One, two, three, 4, 5, 6, 7. Okay? So 6 in this group, 7 in this group. And so let's do this. Now, this is the research, and here's the issue. When you get out of this stats class, you might do a project like this. Whatever your major is and whatever your interest is, you might have 2 groups, right? We don't have any population parameters. That is, we don't have mu, we don't have sigma, and we have 2 groups. And so the question is, well, what statistic do we use? Well, if you have 2 groups and you're looking to see whether there's a difference between the 2 groups, just like we've set this up, then that's a 2-sampled t-test. Okay? Very common kind of a statistic where you're comparing 2 groups. And in fact, I always, when people take this course, even if you do well in the course, sometimes, the next semester you're like, I learned this stuff, but I don't know when to use what, and I don't know, it's all confusing. Well, T for 2. I always tell people, remember, T for 2. And if I was in the classroom, I'm a little jammed up here because I got this close, so I'm not gonna make you suffer through my dancing. But there's a song called T for 2. Do you guys know it? dee, ba-dum, ba-da-da-da-dun, da-dun, dun, da-dun, da-da-da-da-dun, da-dun, 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 ba-ba-da-da-dun, da-dun, dun, dun. Okay, that's T for 2. That's me dancing. I would dance in class. And there's a reason for that, because it's so weird that I'm hoping you remember it. T for 2. You got two groups that you want to compare. It's T for 2. And so let's do our first two steps, which is pretty straightforward, I think. The null would say what? That the group without the artist statement is going to be equal to the group with the statement. Okay? It's going to make no difference. By make no difference, I'm saying if we subtract these two means, we should see 0. No difference, right? The alternative would say, hey, and I'm doing this research, I did this research because I thought it would make a difference, right? And so the alternative would say, listen, people without the artist statement, they're going to rate the art differently than people with the statement, okay? Or I can say, listen, when I compare, that is, subtract, it's not going to be a 0 difference. It's going to be something other than 0, okay? So, step 1, just like we've done before, right? Step 2, let's do our critical values. Alpha level 0.05, and this is typically, I mean, it probably has happened before, people will raise their hand and say, do we always use 0.05? Do we always use 0.05? You can use anything you want to use, but for our class, we're pretty much going to use 0.05. The reason that we do that is because scientists, psychologists included, researchers, sort of say, listen, this is the minimum that we need to show there's a difference. Because remember, this is the probability of making a type 1 error. I don't want it any more than 0.05. Type 1 errors are no good. So I'm going to keep it low. I don't want to go too low because then it's going to be hard for me to see a difference. So 0.05 is kind of the standard level for significance. Okay. Now we have a T. So I want to say, what is the critical T value? Now I'm going to ask you, what are the degrees of freedom that we have here for this experiment? What's the degrees of freedom? Well, N is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. N is 6. Degrees of freedom then here is 5. Okay. Over here we have an N of 7. Degrees of freedom in this case then is 6. We're going to combine the 2 degrees of freedom. So this is going to be a T test with 11 degrees of freedom. So let's look at, I got to go get my book now. Let's look at the appendix. Can you guys find it? Can we see what the critical value is? Hold on. Okay. T for 2. T for 2. If you can remember that, I'm telling you, it will really benefit you, because the most common question I get as a stats consultant is, well, what test? I want to compare these two. You know, people know what they want. I want to compare these two. And I'm like, oh, T for 2. T for 2. So let's look at the critical value. Everybody with me here in my book? 2.201. So that's the critical value, plus or minus 2.201. Okay. I want to get the mean for my group without the artist statement, my mean for the group with the artist statement. We know we're going to need those. That's basically the ultimate, question. So let's see if we can do this right. 7, 16, 22, 24 divided by 6. That sounds like 4 to me, right? I did that without my calculator. I'm going to check with the calculator, but damn it, I can add numbers, right? 7 plus 9 is 16, plus 6 is 22, 24 divided by 6 is 4. Okay, what about this one? 11 and 14, that's 25, 34, 42, 50 divided by 7. 50 divided by 7. So that is 50 divided by 7 equals 7.14. Okay, 7.14. And let me just check with my calculator because I don't want to be wrong, man. So 11 plus 14 plus 9 plus 16 equals 50. Okay. So there we have our means. I know I'm going to have to get the sum of squares for my group without, sum of squares for my group with the statement. Okay, so let's calculate that. Oh gosh, I should have done this ahead of time, but we can do this. Let's do this together, right? Let's do it together. Sum of squares equals I've already calculated that. That's 24 for this group, right? The sum of the x's. So let's do this. 24 squared, I'm trying to figure out here, divided by 6. So that's 96 here, okay. And then I'm going to do 3 squared is 9, plus 16, plus 16, plus 25, plus 36, plus 4 equals 106 minus 96 is 10. Is that correct? Did you guys do that? Okay. Let me check that second number again. 24 squared divided by 6, 96. Okay. A little bit messy. That's okay. Let's get our sum of squares for the second group. Let's get our sum of squares for the second group. Okay. So the first number, because I know my squares, this is going to be easier for me, right? If you don't know your squares, you have to rely on a machine, and then it makes it more difficult. 5 squared is 25, plus 36, plus 49, plus 49. Everybody see what I'm doing? Plus 81, plus 64, plus 64 equals 368 is the first number, 368, okay, minus, remember it was 50, we're going to square that, divided by 7. Everybody with me? Everybody with me? This was 5 squared plus 6 squared plus 7 squared plus 7 squared, okay? Let's do this. 50 squared divided by 7, 357.14. 357.14. So 368 minus 357.14. 10.86. I'm looking at those two, and I'm wondering, they should be similar. Those are pretty similar. So my assumption of homogeneity of variance, that's H-O-M-O, homo, same. Homogeneity, G-E-N-E-I-T-Y. And if I was in class with you guys, I would force you to say that. I get a little bit frustrated when college level students are like, the homogeneity, I don't know about, no. Homogeneity of variance. Okay. So let's do this. We're going to do our t-test. We're going to compare without the artist statement with the statement. Well, we got those numbers. And then we're going to divide by little s with that weird subscript. Okay? So there's the formula. That's what we need to do. Well, the means we have, right? The means we have. The mean for without is 4. And the mean when we have the artist statement is 7.14. Okay. So pretty good. We got the numerator. Now we need to get this value. You will have the formula. So what is the formula here? Pooled variance over N1 plus pooled variance over N2. Take the square root of it all. Okay. How do we get the pooled variance? Sum of squares for 1 plus sum of squares for 2 divided by degrees of freedom for 1 plus degrees of freedom for 2. Okay? You don't need to memorize the formulas. That's what's so cool. But we need to keep our wits about us when we're thinking about the conceptual issues, right? This basically is our guess for sigma. It ends up being our guess for sigma squared. That's okay. We're going to undo that. This is our guess for sigma. This is our central limit theorem step. This is our statistic, difference over variability. Okay? Don't get lost in the formulas, you know, and people are like, I don't know. No, you just try to stay calm, okay? So let's put this in. Let's just put these numbers in. This is, the sum of squares for the first group is 10. Sum of squares for the second group is 10.86. 10 plus 10.86, 20.86, right? Degrees of freedom for the first group is 5. Degrees of freedom for the second group is 6. So 20.86 divided by 11. So it's 1.90. 1.90. That's the value for SP squared. That's it. Once in a while, people will want to square this because they see this. No, this is the formula for the pooled variance, okay? This whole thing squared. This is the formula. We just plug the numbers in. That's what we got. Now we're going to take this value, plug it in here where you see the SPs, right? So this is going to be 1.9 divided now by n for the first group, which is 6, plus 1.9 divided by n for the second group, which is 7. Degrees of freedom, n. Follow the recipe, okay? I mean, the reason I say that, folks, and I know that people can just make a mistake, but don't get flustered. You'll have these formula. Don't get flustered. Just put the numbers in where they belong and follow the recipe, okay? Of course, we're going to take the square root of this. Don't forget that. That's the biggest error that people will make. Okay, 1.9 divided by 6 is 0.32. 1.9 divided by 7 is 0.27. I'm going to take the square root, okay? So I have what? 0.59. Take the square root, 0.77. Everybody with me? 1.9 divided by 6. Let's double check. 0.32, okay? 1.9 divided by 7, 0.27. We'll add those together, 0.59. Take the square root, so it's 0.77, okay? 0.77. Let's plug that in. 0.77. So our t-value, 4 minus 7.14 equals. Now we're going to divide by 0.77, and we have a t of 4.08. Okay, that's our t-value. Everybody know what we're going to do here? Everybody know what we're going to do? Of course. I mean, that's huge. Let's look back at our critical value, 2.221. So this is way out there. Remember what these ratios tell you, okay, please? That's telling me that the difference that we see is a little bit more than 4 times the variability. The difference that we see is a little more than 4 times the variability. That's huge, okay? And so let's do the statement, right? We're going to reject the null. We're going to say that providing an artist statement to people before they look at abstract artwork increases their liking of that artwork, okay? Increases the liking for the artwork. So blah, blah. I'm not going to waste another sheet of paper here. You guys are with me? Reject the null. So it appears that providing the artist statement increases liking for the artwork. Okay. Then in parentheses, we're going to put a t-value with 11 degrees of freedom is equal to 4.08. It's minus 4.08. Okay. And then p less than 0.05. So in this case, we call this a statistically significant difference. And so I did this for abstract artwork and I did it for realistic artwork. And it was really interesting because what I found was certain artist statements affected people's liking for the artwork and certain artist statements didn't. So it wasn't a general thing, but it was a certain type of statements. And I spent another couple of years because what I found was people that wrote more nostalgic statements caused people to like their artwork better. And again, if I had a little bit more technological savvy, I would show you the actual artworks that I used. And I was able to publish this paper in a journal called Empirical Studies of the Arts. So it was really kind of cool. And it sort of confirmed my belief that if people know what's going on with abstract work, they tend to like it better. So those are 2 examples now of 2 sample t-tests. T for 2, right? Dun, 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 dun. Okay. T for 2. If you want to compare 2 groups, it's use the t-test for 2 groups. So the next class, take a look at both of these t-tests, read the chapter. If you need to, you can, suffer through this video again. We're going to combine the variability from 2 groups. That's called pooled variability. And that's because we want the best guess for sigma. So I'm going to use both samples. I'm not going to use just one or the other. But in order to do that, I'm going to have to do 2 things. Number 1, I need to assume homogeneity of variance. The 2 groups should be similar. Okay? That's what that means. The assumption of homogeneity of variance means that the variability for the two groups should be similar, should be equivalent. I wouldn't go as far as saying they should be equal. That's kind of restrictive, but there should be homogeneity there, okay? So that's an assumption that we need to have. And if they aren't similar, then we're going to need to do a different statistic. I'll talk about that the next time. But I also want people to understand how we can make that assumption. If the two groups aren't different, then that means they're coming from the same population, so we should be able to pool them, okay? But here's the kicker. This one is the lesser obvious one, lesser intuitive. If we end up rejecting the null, like we did here, we said, hey, the artist statement group is a different population than without artist statement. That's what we're saying. It comes from a different population. But even if we reject the null, we're going to say that the groups, that the treatment just pushed the curve up the number line, but it didn't change the variability, okay? So it just took the without statement and it went like this, it pushed it up, but it didn't change the variability. So if there's no treatment, they came from the same population, we can combine them. But even if there is a treatment, we're assuming that the underlying variability of the two populations is going to be the same. Okay. So I went a couple minutes over this time, but that's okay. I'll do a little bit shorter the next time. So stay healthy, everyone. If you have questions, please email me, okay? Or we could do a Zoom or whatever's necessary. But it takes a while to go through this. Do this, read the chapter. Same steps as a single sample t-test. It's just that we're going to combine the groups. Okay. So I will see you the next time. Stay safe.